name is I am from AISSMS Institute of Information Technology. Today we will be talking about Naive Bayes algorithm, which is one of the most popular and simple machine learning algorithms based on probability theory. Naive Bayes is mainly used for classification problems, especially in text classification, spam detection, sentiment analysis, and recommendation systems. It works on the principle of Bayes theorem, which helps us find the probability of a class given some evidence or features. The name naive comes from the assumption that all features are independent of each other, which is rarely true in real life, but surprisingly, the model still performs very well in practical cases. Now let us take a look at the Bayes theorem. Here the formula is probability of A given B equals to probability of B given A multiplied by probability of A whole divided by probability of B. In the context of naive Bayes, A represents the class and B represents the set of features or attributes of the data. So the theorem helps us find which class is more likely for a given set of features. Now, talking about the naive assumption. The key assumption made in naive Bayes is that all features are conditionally independent given the class. For example, if we are classifying an email as spam or not spam, naive Bayes assumes that the presence of one word like offer is independent of another word like free. Even though this assumption is unrealistic in many situations, it simplifies the computation a lot. Instead of calculating complex joint probabilities, we can simply multiply the probabilities of individual features. This makes naive Bayes fast, efficient, and suitable for high-dimensional data like texts or documents. Thank you.
There are mainly three types of naive Bayes algorithm. First is Gaussian naive Bayes. It is used when the features are continuous and normally distributed. Then the second one is multinomial naive Bayes algorithm, which is used for the distinct counts like word frequency in the text classification. Then the third is the Bernoulli naive Bayes. It is used for the binary features where the data is either 0 or 1, such as presence or absence of the word. In this, each of these variants is designed to different types of data, but all of them follow the same Bayes principle. So it is actually works in the steps. The first step is convert the data set into the frequency table. Then second is the calculate the prior probability of each class. Then find the likelihood of the probability for each feature value which is given to the class. Then the fourth step is to apply Bayes theorem to calculate the procedure probability for each class. Then select the class with the highest probability as the output. So essentially, naive Bayes compares the probabilities across all classes and chooses the one that's the most likely to be true for the given input. So let's take a look at the example case study to understand this better. Let's take an example of the email spam classification. Suppose we have a word like a offer, discount, and a free. The algorithm calculates how frequently these words appear in the spam email versus the normal email. Based on this, if a new email contains the similar words, the model computes the probability of it being spam using Bayes theorem. Finally, if the probability of spam is higher than a not spam, it classifies the email as a spam. This is a simple but very effective real-world application of the naive Bayes. Thank you.
I am going to explain the advantages of Naive Bayes. Naive Bayes has the several advantages that makes it the popular choice for the classification task. It is the simple and easy to implement. It requires the less training data compared to other algorithms. It is the fast and efficient even for the larger data sets. It performs well in the text classification and multi-class prediction problems. It can handle both the continuous and discrete spam detection, documentation, categorization, and sentiment analysis. Limitations, however, naive Bayes also has some limitations. The major one is the assumption of the feature independence, which is rarely true in real world data. It is not suitable for the complex relationship between the features. It is a particular category in the dataset has zero probability for the given feature. It can cause the problem in prediction. This is known as the zero frequency problem. And finally, it can be less accurate and more advanced module like decision trees and random forests, especially when the data isn't well distributed. Despite these limitations, its simplicity and speed makes it great baseline algorithm for many problems.
My name is Divya Rahane. Example case study. Let's look at another real world example, sentiment analysis. In this case, Naive Bayes is trained on dataset of movie reviews labeled as positive or negative. Each word in a review is treated as a feature. The model learns how often certain words appear in positive and negative reviews. When a new review comes in, the algorithm calculates the probabilities for both classes, positive and negative. It predicts the class with higher probability. This approach allows Naive Bayes to quickly and accurately determine the sentiment behind a piece of text. Conclusion to conclude, Naive Bayes is probabilistic and supervised learning algorithm that's simple yet powerful. It is based on Bayes' theorem and assumption of features independence, making it computationally efficient and easy to implement. While it has some limitations, it performs text-based and real-time classification tasks, makes it one of the most practical algorithms in machine learning. Thank you.